Hello, I'm Philip Stoten. I'm here at Productronica 2017 on the SCOOPstudio, and I'm joined by three gentlemen to discuss cyber-physical systems and the need for not just feedback loops, but feed-forward loops and the connection between equipment. We've got Peter from Panasonic, Harald from Koyoung, and Torsten from the ASIS Group. Thanks for joining me, guys. Let's start by just setting the scene. Where are we at the moment in terms of those feedback systems? You know, I think 4 years ago we were talking a lot about feedback loops between print and SPI. There's now so much more going on.
So with Panasonic, we're actually utilizing this in a process called APC. APC stands for Advanced Process Control, and this is where we take in the feedback from the screen printer, from the SPI, back to a screen printer to be able to adjust the offset. But also we feed that forward to the SMT machine so that we can actually place the component to the paste. And this allows better alignment during the reflowing process, so you get better wettability of the solder, and therefore your quality improves. And that's what it's been mainly driven by. It's been driven by quality. Developed, I think, for the mobile phone market originally. So the problem there is that the handy size, they don't want to increase it too much, but you want more and more functionality. So therefore you need more and more components. The components get smaller and the proximity of the components to one another becomes tighter and tighter. And it was to improve the yield rate from those kind of products. But we've been able to move that forward for other products as well. So
yeah, I think that's really interesting. And when we see industries the way they operate now, one industry might lead the way, but that technology is going to find its way elsewhere. From a Koyoung point of view, it's all about producing that really good data that these guys can then manipulate. But you've also got to participate in the ecosystem, Harald.
Of course, it was a hard time to convince the partners before or after the system that we are not try to prove that they are failing. We try to prove that they are on the right track. And accepting this as a valuable aspect, it becomes more into partnership. We are partnering, I think, more than 4 years already with Panasonic and with the feed forward and feedback to the printer, because we realized that it's necessary to start the process of machine-to-machine communication. As we discussed several times this week, Industry 4.0 is not just a marketing gig. When you take it serious, you need to cooperate, you have to partner. We have the experience on machine-to-machine level, that was the closed loop, but to improve processes, it's much more to interact. And that's what we do already with the printer manufacturer, to make sure that we can help to adjust the process in a very progressive way, quick and straightforward, to get a high yield.
From your point, I'm excited here because I feel like I've got a production line now. I've got a printer, I've got an SPI, and I've got placement here. From your point of view, it's important that the machine after you isn't just policing your performance and saying yes, no. They're giving you feedback that can improve your process. Within the ASIS group, that's a really important flow of data, I guess.
Actually it is. You know, as we started almost 10 years ago with closed loop and we spoke to different partners in the industry about closed loop, there was like a big astonishment. What are they doing? They want to have data as information so we can improve our own process. And I think it took at least 4 to 5 years until we got a little exception of those partners to also open their informations to others. Now, closed loop became a standard a couple of years ago, but with the introduction of Industry 4.0, everyone realized that we need not only a personal networking, we need a professional networking on the machine base. With information, with data we can trust on, we can share process parameters, and this is the only way we can go forward and optimize our complete line. And this is not limited to the printer or limited to a pick and place. It's also going on to laser marking or routing systems. And this also covers the complete ASIS portfolio. We just need to identify the information we need. We need the right partners to do this. And from there, we really can start to build solutions for the customers.
Yeah, solutions with process improvements. And you know, you have this nice connection between the three machines, but if we were a full production line here, there'd be there'd be a reflow guy up here and a whole bunch of other machines. How far can the loop that you produced go? And when you look at where Harald sits in terms of SPI, can he actually be influencing what's going to happen on the reflow oven? Adjustments that maybe need to be made there. What's your view on that, Peter?
I think the whole point is, in order to maintain quality, you've got to have the feedback so that if there is an offset to be adjusted, we're going to get that offset so that we're able to correct anything. So this is creating the closed loop control. And also then with the feed forward, you're telling the machine, okay, where to place the components. You move further down the line, you then have the AOI, okay? So the AOI is now looking, well, exactly how did we place it? Were those offsets that we created in the first place really, really working? And so then we can feed that back to the placement machine to actually really close the loop as we're talking. So that's where it starts to encompass the whole production line.
Yeah, and the information that you can deliver to the line, how far can that go? I mean, it's obviously needed either side of you, but can it go beyond that?
It goes beyond because due to the fact that from the traceability aspect, the data are stored. In the past, we just registered good, bad, and we hope that it goes further. With the precise data analysis and the data collection, we can even review later on the complete process if there's any obstacle along the line, along the production process, even to the final product. So delivering the first level during the production process, but also delivering the big picture of not only one single product, of a family, of a part number, of a manufacturer quality. We are talking about component sizes. People have to execute the components what they get from the purchaser. But nobody has the power to blame the purchase department of the cost cutting, buying cheaper components. And this can root cause a lot of problem rework. With a precise measurement, you can exactly allocate when the things happen. And if the component size is changing, we can inform the pick and place, we can inform the printer, we can inform even the production management that something happens. Please check if you are aware of. So these preventive actions are more valuable than just to catch a defect. The communication between all of us helps to improve the yield. And this is the first part. That's easy because it's obvious. But to maintain this yield, then you have to really dig into the details. And that becomes the complexity. Because the obvious things, that's what the humans did already for years. It becomes more difficult with the smaller structures, but still possible. But really to keep ongoing humidity, temperature, operator, all these kind of factors are influencing. If you don't know the influencers precisely, you cannot eliminate them. That is important.
Yeah, and it's this huge amount of data, isn't it, Torsten? As Harald says, it's not just going beyond the machines that are here, but it's going beyond the factory walls into the supply chain. You work in a lot of parts of the ecosystem. You see that willingness to collaborate and that willingness to share data in an open way. Is that happening throughout the factory and extending beyond that?
I think we actually made the first step also to open us, because we started a project with the KPO. So I open, for instance, the printer. So we get a feedback which controls the printer. And this is the first stage of a new time for communication. This is not just tell me something, I may do something. This is, okay, here I am, tell me what to do. So the printer acts to actually values we get from, let me call it just from the SPI, which is not in that case true because it's more behind. And then we do a special test procedure to find an ideal process in the beginning. And this is the first step we start in front of the line. And that, of course, can, be repeated also to other processes and other components of the line. And that helps the customer because he does not need 100% specialist to do it, because the machine can introduce new processes. We as specialists never thought about it because we are, let's call it by time, a kind of an idiot, looking too stiff to a certain thing. And this will help us also to see different things. With the sensors, we got sensors around. And these introduce new ways of solutions. And that helps us on the process of printers and probably also on other processes in the complete manufacturing line.
Yeah. I mean, I think it's really interesting to hear what you're saying. And when I look back 2 years ago, this was kind of the stuff we were talking about, but talking about as possibilities. So I feel this year, particularly at Productronica, with a lot of conversations I've had, we've got real solutions. We've got real offerings that are smart factory to the customer. Last question, let's just roll forward to 2019, 2 years down the line. How far do you think we can get with this? And what's going to be the triggers that disrupt the market? Is it going to be artificial intelligence, augmented reality, or just more of this open, really, value-added communication between companies?
I think with the open communication that you have now with the machines, and I mean this started in Panasonic with our own equipment, and we soon realised that we're really limiting this technology because not many customers have our printers, or not many customers have our specific AOIs. They are spread out. So you have the Co-Youngs, the Viscoms, and so on and so forth. So we have to open up if we want to make this benefit for the customers. So moving that forward, you can now supply data for everything from remote control. So you can remote control the lines so that you're not waiting on operators to walk from one side to the other just to resolve a simple error. So that's going to speed up your productivity. So it's all about maximizing your overall equipment efficiency by making more efficient your operators, having less defects, so your quality is improving. And also, for example, with AOI and SPI, you can maybe inform the rework process. Hey, there was a slight problem here, it actually passed, but maybe just take a look.
Yeah.
So you start to focus people's minds so that we're always catching anything that goes wrong.
So more intelligent systems. What about things like digital twins of lines and all that kind of stuff, Harald? What's going to be here in 2 years' time?
I think we introduced this year the first time, especially in programming, auto-programming based on AI engines. The individual programming, the individual setup of programs is the highest risk to lose control of the quality. The qualification of the operator, of the engineer who programs the machine, doesn't matter which machine, is always a risk. Based on the data we grabbed and collected from all process steps before and after ours, and luckily we have SPI and AOI, we see the whole process, we realized that we have so much knowledge about the process that we are utilizing it for statistical debugging. We know how 1 million components has been placed, and we know exactly the tolerance. Why we have to go for wide tolerance like IPC, 25%, when the process is stable with 3%. So this is a kind of learning we applied already as a first step to get tighter tolerances, to control the process much more in detail as we ever did in the past. And in 2 years from now, we will change. I think the change of our programming, of methodology, of analysis will be changed. We already stepped into, we see a clear advantage of analyzing this massive amount to help the operator, the programmer, to make the right decision in the right moment and not to wait too long until it's gone and it's too late.
Yeah.
I think this is the part, we are on the way, based on our cooperation, the findings, and at least the content of the data. It's not just the data, it's what you generate out of the content. And this is significant, obvious when you start to analyze, really analyzing.
Analyzing data, using good data to create learning experiences. Last word for you, Torsten, apart from an even bigger booth, what do you think you're going to see here in 2019?
I do have, in my mind, some real clear picture about that. But before I come to this, we still have a long way to go because there are still limitations which hold us back to sharing data or all the data we need. In some states, areas and countries, you're not allowed to do this and that with data, but these data we need. I fully agree with Harald. With the data we get, we probably have to rewrite some of those requirements today what is within our specifications because we learn again. And on the other side, we need to talk with our people around because a lot of them are afraid that what we are doing is their job and they lose their job. Now, time is changing, but we still need people. We probably do not need people to move parts around, but we need people on different jobs. And if we have sorted all of this out, I think we can have very good products produced in very low costs. But we need all of those things to do. The big data, what everyone has in mind, is at the moment, in my opinion, only a phrase. There's a lot of job to do, a lot of work to do, until we really can utilize this in good products. We started, we talk, we learn every day about that. We put the right measures to it, so to adjust that. And in the end of the day, I think we will have a machine. You say, I like to do this. You put all your materials in, or even you get told what materials you need for this, and in the end of the hour you have a perfect produced board product coming out of your manufacturing line. That is the vision.
That's smart factory nirvana, and that's where we're heading. It's an augmented age. It's an age where you need operators, but you're augmenting them with big data. You're augmenting them with what the machine can do. I'm looking forward to being back here in a couple of years and talking to you guys and seeing how much of this comes true. Thank you so much for your time, and enjoy what's left of Productronica. Thank you.